Hi, so I want to talk to you guys about how tessellations work and what they are, and kind of just, play around with some regular polygons and see if we can create some tessellations ourselves. So, as you can see in front of us, we have a floor design that has or contains a tessellation created of regular polygons, where a regular polygon is a polygon whose sides are all congruent and angles are all congruent. So you can see all these hexagons appear to be congruent shapes, and they create a sort of pattern or design here on the floor. So we're going to want to answer two questions using these tessellations. And the first question would be, why can't tessellations not be made with all sorts of regular polygons? And, we'll dive deep into that a little further on. So, we'll kind of play around, and you can already tell not all regular polygons are going to be able to create a tessellation, but we got to figure out why. And then we're going to also explain which regular polygons can be used to make a tessellation. And, that'll also go in hand with answering the first question. And we'll just, use our abilities to create transformations to create these shapes and tessellations. So here we're going to create two standards, just focusing on transformations, how we can create reflexes across axes or lines of symmetry where we can just, create other shapes along those axes. So first we want to create hexagons. Just want to recreate that picture that we had. So we're going to scroll down to polygons and then click on a regular polygon tool. And then we're going to create 2 points and click 6 vertices. So GeoGebra is a mathematical program or geometric program that can create these dynamic shapes that should already be congruent, at least with it, depending on its sides and angles, since we clicked on the regular polygon tool. But we will check it out. We will click on this side, and this side, and 1.8 are all equal, so has congruent sides, and we will check angle CHG, and as you can see, the angle is 120 degrees, and angle GFE, and that angle is 120 degrees, so this is a regular polygon. So we're going to create another regular polygon, a line and line of symmetry. So we'll see, let's do CNH. CNH is going to be our line of symmetry where we'll kind of reflect our regular polygon to. So we'll create 6 vertices again. And as you can see, it's kind of been reflected along that line right there and create another regular polygon. That should be the same shape. And we will just make sure, test it out. And so you can see, it all has 1.8 measurements for the sides. And if we could do angle KJI, so you can see 120 degrees, and then IH, oh, accidentally right clicked, IHC, it's 120 degrees as well. So let's create another regular polygon, another hexagon right here along I to H with 6 vertices. And as you can see, we have another regular polygon, which should already be congruent. As you can see, this side is equal to this side, and this side is equal to this side, so that all sides should be congruent to 1.8 length. And if we see here, we're about to create a full circle. So if we measure this angle, IHM should be 120. So that gives you a full circle, which should all equal 360 if you add those all three together. So let's test out another regular polygon and, see, what else works and what else doesn't work. So let's see what happens if we use a pentagon. Let's see. So if we do 2 points and then click 5, we're going to create a regular pentagon, or regular polygon, which is a pentagon. Because it has 5 sides, we'll measure the sides just to make sure they all appear to be 2, which is good since all sides will be congruent. And we'll measure angle QUT, it's 108, QSR appears to be 108, and UQR, that's 108. But I'm going to move the number so you guys just can make sure, just so you guys aren't confused. As you can see, 108 degrees here, 108 degrees here. So let's go back to the regular polygon tool and, use a line of reflection or a line of symmetry to create another reflection. So go U to T and use that as our line of reflection, or line of symmetry, apologize. 5 vertices. And it appears to be the same, just to make sure it's that. Let's measure the sides, and they all appear to be 2, and measure this angle right here, ZUT, that's 108. So as you can see, we want to create another circle right here where all the points are going to be centered around, or all the polygons are going to be centered around. So if we select another regular polygon and go from U to Z, and we click 5, ooh, there seems to be a slight problem. But let's make sure this angle is the same. So if we do angle ZUC1, it appears to be 108 degrees. But it does not appear to equal 360 since we're missing a little sliver right here. And if we create another regular polygon to Q to U, click 5 vertices, these two pentagons are overlapping each other, so that does not work. Even though if we measure the angles on this overlapping polygon from E1 to F1 to Q, it does equal 108 degrees. So one thing we can really notice is by transforming these regular polygons into lines of symmetry, we're going to be able to create, a little circle here. That is standard for a tessellation. But as you can see, since this is equal to 360 degrees and these angles are each 108, except for this angle right here, you can already tell that this is not going to be able to be a tessellation since it is not divided 360 evenly. So what happens if we try out one more regular polygon? So let's see what happens if we do like a triangle, Would that create a tessellation? So let's see. If we do regular polygon, create 2 and then click 3 vertices and then reflect around this line of symmetry, click 3, and I did it the wrong way, apologize, and 3, and then go K1 to G1 along that line of symmetry, click 3, and it appears that, looks like we're making another hexagon, which makes sense, since a triangle will be able to divide hexagon evenly. And all these triangles are congruent in the sides and angles. So, if you create an equilateral triangle, that is basically a regular polygon. So if we measure the angle right here of N1, G1, and N1, we should get 60 degrees, which makes sense because 360 will be divided by 66 times. But, if we did another different polygons such as like let's say octagon, just make sure it's not just even ones that will work, and we create a regular polygon there, W1 P1, click 8, and then we create one from Q1 to P1, click 8. So you can see these are overlapping and creates a sort of like diamond or rhombus right here. Oh, did I want to move that? There we go. And then if we measure these angles, you can kind of tell W1, P1, Q1, that angle should equal, let's see, equals 135, which if you divide 360 by 135, you will not get 360 evenly. So, meaning a tessellation can only be created by polygons whose angles can divide 360 evenly. So that answers the question about which polygons can and cannot create a tessellation, and which regular polygons can be used to make a tessellation. So, if you want to come onto GeoGebra and test out these tools, this is a completely free site. You have all these tools to use, and the only tools you really need to test out this hypothesis, test out your hypothesis, is regular polygon tool, the angle and distance or length measurement tools, and then just the move tools to move around and just test it out. So I definitely challenge you guys to, try any polygons and let me know if one does work. But otherwise, just test it out for fun and see, what you can make and what tessellations, would be cool to, create your own designs with. And thank you guys. Have a nice day.